Hey, this is Patrick Sullivan. Welcome to my shop. Anytime you attempt a project with angles in it other than 90 degrees, you immediately run into the problem that your table saw almost certainly lacks any high-precision way of cutting angles. The miter gauge that comes with the saw is supposed to guide angled cuts, but almost all miter gauges are inadequate in one way or another. Most are too small to show fractions of a degree, and some are especially tiny and hard to read. There are some good aftermarket gauges, but they're fairly expensive, and even they suffer from the inability to cut long, narrow angles. We can solve all those problems and do it pretty cheaply. We can also make a device that's fundamentally safer to use. Here's the finished device in action, making a long 10-degree cut that is accurate to about 1/10 of a degree. The key to making a precision gauge in your own shop is the incredible accuracy of modern computer drawing programs and printers. What, you don't have a CAD program? No problem. I do, and I've posted full-size templates on my website, which you can download for free. I took the PDF file to a FedEx store to use on their oversized printer. Incidentally, if cost is no object, then this design could be engraved on aluminum with a CNC router. However, we're going to take a much cheaper approach in this video. FedEx has a huge laminating machine which sandwiches the print between two sheets of really tough polyester film, similar to Mylar. The whole thing cost me about $10 to $12 US. Trim the film so one edge is exactly parallel to the lines on the print. This straight edge helps you to align the print when we attach it to plywood. I tested a bunch of adhesives to see what would stick to laminating film. Very few ordinary glues work, and that includes CA glue and epoxy. Rubber cement does work. However, 3M's high-strength 90 spray adhesive was by far the strongest hold. I couldn't pull it apart no matter how hard I tried. Unfortunately, the can I used had a defective spray nozzle, and instead of a nice, wide, smooth spray pattern, mine shot out a thin, fat jet. I tried to compensate for this by quickly spreading the glue before it got too sticky. These glues bond on contact, so you cannot reposition the piece once it touches down. I positioned it by myself by spreading paper under the plastic to control where it touched, but it would have been much easier if I'd had a second pair of hands helping me. Place a smooth surfaced sheet of plywood over the film and clamp it firmly and immediately. The glue holds instantly, but it takes about 30 minutes to get hard. We want to flatten any irregularities in the glue while it's still relatively soft. Next, drill a hole at the exact intersection of the lines on the plan for the pivot. The hole size needs to match the diameter of the pivot bolt exactly. The first step is to route a 105-degree arc all the way through the film and the plywood. I experimented with several router bits and found that a downcut spiral bit gave by far the cleanest cut in the plastic film. I mounted my circle jig on my router, pivoting on the bolt that we just drilled. If you need a circle jig, see my earlier video showing how to build this simple device. The link will be in the description below. I cut the slot in 4 passes. The router could handle deeper cuts, but I think I get cleaner results by going a little slower. Then I flipped the workpiece over, remounted the circle jig on the underside, and routed a recess. It needs to be deep enough to recess a bolt head and a large washer. I used a 3/4 inch or 18 millimeter router bit and removed the rabbet on either side of the slot. Don't worry about small voids or defects in the interior of the plywood. They won't matter. This recess needs to be wide enough that the fender washer you use will not touch either edge as it slides along. The next step is to make a runner that fits exactly in the table saw slot. It needs to be located so the edge of your new gauge will be a little to the right of the saw blade. I cut a shallow dado a little over 1/8 inch or 4 millimeters deep that fits the runner exactly. This dado guarantees that the runner will be parallel to the reference edge of the miter gauge and guarantees that the runner will not curve or warp, which would cause it to bind in the table slot. I made my runner out of white oak, which wears like iron. Before you glue the runner in place, we need to remove some wood where the runner crosses the circular slot to allow the bolt head and washer to slide under the runner. Also, before we install the runner, this is a good time to drill holes for some T-nuts that will anchor the removable hold down. These holes need to be drilled from both the top and the bottom of the plywood, so drill a tiny pilot hole at each location to index the larger drill bits so they'll align nicely. Turn the workpiece over and drill a shallow recess in the bottom to recess the base of each T-nut. Then on the top surface, use a sharp bit and take a few seconds to penetrate the top edge of the film in order to get a cleaner hole. Incidentally, there is no magic or precision in the location of these holes. If you later find that you need another anchor, you can easily add it after the whole jig is finished. I laid down a bead of medium thickness CA glue under the base of each T-nut to help it stay put. This may not be necessary, but it's good insurance. Drive the T-nuts into place with a hammer and a large bolt or a metal rod until they're fully embedded in the plywood. Now, finally, glue the runner in place and clamp it. Drill a recess in the bottom of the plywood for the head of the pivot bolt and a washer. Now set the miter gauge in its slot in the saw and trim off the narrow strip on the right side. This produces a zero clearance edge, which will allow you to see exactly where each angled cut will end up. This is a really handy feature of this jig. The fence starts with a piece of 2-inch or 50mm aluminum angle. It is 24 inches or 50 centimeters long and 1/8 inch or 3 millimeters thick. I marked a reference line down the center of the leg by scribing with my calipers. Drill a hole for the pivot bolt accurately centered on the reference line. It's about 3 inches or 75 millimeters from the end. Mount the fence on a bolt in the pivot hole and mark exactly where the center of the fence crosses the circular slot in the miter gauge base. Note that we can't just mark where the edge of the fence crosses the slot, so I made a temporary measuring stick that will allow me to locate the hole in the aluminum fence. Next, I laid out the location for the cutout for the magnifying cursor. I will show you how this cursor was made in just a few moments. I cut out this hole with my scroll saw using blades designed for cutting aluminum. However, this could be cut out with a coping saw or a fret saw. After I tested this fence, I decided that I needed a longer cursor so I could read the angle numbers more easily. So I made a new cursor and extended the cutout. Finally, I rounded the corners. I found those sharp corners very annoying. Although we could simply use a small rectangle of flat acrylic for the cursor, having some magnification is very handy and desirable. I bought a small magnifying ruler on Amazon. I then scribed a line on the flat side using my calipers. The purpose of the scribed line is to create a very thin, very shallow trough that will direct a pinpoint and trap some ink. I used a red acrylic ink that I had on hand, but you could use ordinary India ink and probably several other inks as well. In order to shape the lens, I traced its profile on a scrap of MDF and made a series of cuts on my table saw to remove the wood down to the line. Then I inserted the ruler and taped it in place. I cut away enough plastic on both ends to create a thin tab that I could compress with a screw head to hold the lens in place and to allow a small amount of adjustment from side to side. Note that I removed a little plastic from the bottom of the tabs as well, so the lens would drop down almost flush with the bottom of the aluminum fence. If the lens is elevated too much above the print, you'll get some distortion in parallax. This cylindrical lens only magnifies in one direction, making the space between the degrees about twice as wide as it appears without the lens. This allows you to estimate the angle to about 1/10 of a degree. 2 screws hold the cursor in place. I drilled and tapped the aluminum fence for number 8 machine screws, which are about the equivalent of M4 metric. I had to cut them very short, so I used an electrician's tool that shears the screws off cleanly. Place a thin nylon fender washer on the pivot bolt and then lower the fence down on it. I also put a nylon washer on top of the fence to protect it from abrasion. A nut holds the assembly together. Don't over-tighten it. On the other side of the plywood base, a thin nylon fender washer separates the aluminum fence from the plastic laminate. Turn the gauge over and insert a bolt and a large steel fender washer into the slot from the bottom. Although I don't show it here, I later put a dab of medium-thick CA glue under the head of the bolt to attach it permanently to the washer. A knob on the top locks the fence to the plywood bottom. Please note that the aluminum fence does not touch the plastic laminate at any point, so wear is minimized. Lay a large, accurate framing square on the base with the cursor in the fence set to 90 degrees. If the square does not align perfectly with the vertical lines, adjust the cursor slightly to correct any error. It's also possible to test for alignment with a large 45-degree triangle or a digital protractor. I cut a strip of MDF the same height as the fence and cut a dado in the center of one side to contain a strip of T-track. Screw the track into place with very short screws. I cut a strip of non-skid tape to fit the front of the fence. It's essentially coarse adhesive sandpaper that's very durable. Drill 3 holes in the upright part of the aluminum fence and insert 1/4" or 6mm bolts into the holes. The bolt heads will slide inside the T-track and can be locked in place with wing nuts or small knobs, as I'm showing here. This allows the fence to be adjusted so it remains close to the cutting edge, no matter what angle the fence is set to. The last component is a simple hold down. I made mine from a flat strip of steel, 1 inch wide and 3/16 inch thick, about 25 by 5 millimeters. This one is 8 inches or 20 centimeters long, and that seems to work fairly well. Cut out a slot in the center to allow a bolt that fits in the T-nuts to slide through easily. Clean up the edges with a file, and smooth the surfaces with a sander. I rounded over the ends and corners so they would not mar either the base of the gauge or my work. I then dip the ends into a resilient plastic coating called Plastidip. It's intended for tool handles, but it really works well for this purpose. It requires numerous coats to develop an adequately thick protective covering over the ends. If you set the fence to something near 90 degrees, you can use this gauge just as you would a conventional miter gauge. If you set the fence angle to a steep angle, then the hold down becomes a convenient and safe way to immobilize the workpiece. The steeper the angle, the more critical the hold down becomes. Please understand that for steep angles, the force of the blade tries to slide the workpiece along the fence toward the blade. If this is allowed to happen, then the work may pinch the back of the blade. This is dangerous because the back of the blade can lift the piece up off the gauge and throw it at high speed. The non-skid tape discourages any sliding movement, but your best security is the hold down. When cutting very short or narrow pieces, like this one, the hold down is mandatory. You never want your fingers this close to the blade. One final tip. If you're cutting a long or heavy piece that will hang off the edge of the gauge, consider placing a scrap of plywood on the saw table away from the blade to support the offcut. This will minimize any breakage at the very end of the cut. Oh, one final note. This is not a picture framing jig. A real picture framing jig looks like this. Asymmetric material like molding requires both a left and a right-hand 45-degree angle. This gauge will only make the right-hand cut. However, I have posted templates for gauges that work in both the right and left-hand table slots if you need both. Okay, that's it. A versatile and highly accurate way to cut many of the angles you may encounter. If you like this video, please hit the like button. If you want to see more, click on my picture to subscribe. Check the description below for the sources of materials and a link to my web page. Thanks for watching.